Hello students, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 16 of a unit electric charges and fields. In previous classes we were discussing about the previous year asked questions. Uh, Moving forward in the same manner, this is the class where we are going to discuss about the previous year asked objective type questions. But before we begin with this, I request you to take your pen and paper, and I want that you guys do the questions with me, and we are going to matching the answers. So let's begin with today's journey. Let's begin. The question given is the magnitude of electric intensity at a distance x from a charge q is E. Okay. An identical charge is placed at a distance of 2x from it, then the magnitude of the force it experiences. So the question is that, let's say, the magnitude of electric intensity at a distance x from a charge q. This is charge q, and you require an electric field at this location. This is x. Yes, and here you have given that electric field is E. If I want to write a magnitude of it, it is a kq by x square. Now move forward. Then they ask that an identical charge, that means a charge having the same magnitude and same nature, is placed at a distance of 2x from it. An identical charge is placed at a distance 2x from it, then the magnitude of the force it experience. If identical charge is placed at a distance 2x from it, then the magnitude of force it experience. This was the q, this was the p, and an identical charge is placed at 2x from it, that this would be the distance x, this would be the distance 2x. And now you require to find out the force on it. So what I know is F is equals to q into E. F is equals to q into E, and E is inversely proportional to the square of the distance. So now your distance is double, now your distance is triple. So your electric field will be, as this increases this will decreases, this increases this will decreases. So your electric field will be reduced, and net electric field will be q into E divided by 4. As this is twice, this should be the decrease. Yes. What was your answer? Was it same? Are you sure? Great job. Let's move to the next question. The charge the charges are at a distance d apart, and if a copper plate, they have intentionally used a copper plate of thickness d is kept between them, the effective force will be. Now, before you start this session, before you start going this must be clear in your mind, that let's suppose this is q1, this is q2, and their separation is x. Then their F in air would be equals to k multiplied by q1 multiplied by q2 divided by x square. Now if this two charges, this is q1, this is q2, has been placed into a metallic region, or certain metallic object has been placed between them, then their forces should be is equals to F of the air divided by k, where k is the dielectric constant of that material. For metal k should be infinite. This all would be clear by you have learned this in previous classes. So now the situation is, let's say this is charge q1, let's say this is charge q2, and this is x. Now between these two charges, yes, they have given a d, sorry, so they have given a d. Between these two charges, a copper plate of thickness d, that means a copper plate is been introduced. If something like this, Then f dash should be is equals to f of the air divided by k. Now as they have used a copper plate, it is a metal, so for copper it would be an infinite, and if it is an infinite, f dash would be equals to 0. So this would be our answer. It would be a zero force. Yes, are you clear with this? Are you sure? Let's look at the next question. Yes, it is of same kind. That go through it very fast. That they have given is when air is replaced by a dielectric medium of constant k, the maximum force of attraction between the two charges should be separated by a distance of what it would be, what it could be. Yes, if f air would be k into q1 into q2 divided by r square. Let's say r is the separation between these two charges, then f in certain medium would be is equals to f of the air divided by k. Yes, so this is decreased by k inverse of times, because this would be a positive number. As this would be a positive number, this would be a moving down. Yes, are you sure? Are you done with this? Will you be able to solve this kind of questions? Are you sure? Let's move to the next question. You today you did it fast. Well done. Go ahead. The next question is, go through this very carefully but fast. What they have given is an electron is moving with the speed of this, it's a 5 into 10 to the power 6 centimeter per second, is shoot parallel to the electric field of intensity. This is the electric field of intensity 1 into 10 to the power 3. Field is responsible for retardation of electrical motion. Now evaluate the distance traveled by the electron before coming to rest. Okay, that electron is going to be at rest, and mass of electron and charge of electron is given. So what you can do, what you can do, what you have supposed to given is that initial velocity is given 5 into 10 to the power 6. Even a final velocity is given because they said it would be come to unrest. An electric field is given, it's a 1 into 10 to the power 3. Now what else is required? Yes, everything is given. So can I write v square minus of u square is equals to 2as? This v would be a 0, so 0 minus of u square, and as it is a retarding, minus of 2 into qe by m into x, that is s. So this 2 would be a gone. S is equals to u square by 2 into e by m. Yes, this was the answer. Yes, now if you put up a value and this, and you are having an answer. The answer approximately came is 7.1 centimeter, but as nearest option is the 7 centimeter, so I will choose that. Are you sure? Yes, yes. Other than the calculation, I understand that calculation requires a time, but did you think this kind of thing in your mind? Did you? Yes. Are you sure? Okay, do one more thing. Do one more thing. I add up one more question. I require that time in which electron stops. You will do it. Even no hint will be provided for this. So do it. Yes. Let's move to the next question. Next question. What is given? Go through this very carefully. You yourself must do it. The data is that two parallel and infinite line charges, that is the plus lambda and minus lambda, are placed with a separation of distance r in free space. The separation is r. The net electric field exactly midway between the two line charges. Okay, so first you need to plot a situation. this is positive charge, that is linear charge density plus lambda. This is minus lambda. The separation between these two is r. It is a midpoint of this. This is r by 2. Even this would be an r by 2. Yes. Now what you require, you require an electric field. Let's say this as a p. Now first we always try to find out the magnitude. So electric field due to positive lambda, and this is an infinite line charge, what would be its value? What was the value? Did you remember the things? Yes, it is in k lambda by r. R is the distance, into bracket sine alpha plus sine beta, when infinite wire is there, for infinite line charges, alpha equals to beta should be is equals to 90 degree. For infinite line charges, alpha and beta would be a 90 degree, and when it is an infinite degree, the things would look like this. This is positive, this is negative, plus lambda, minus lambda. Here the total separation is r and individual separation is r by 2. So if I write electric field due to lambda, it is at k lambda by r. K lambda by r, r is the separation, into bracket 1 plus 1, it is 2. So this is 2 k lambda by r. What about E minus of lambda? Again the same thing, it is at k lambda by r into a 2, because it is having an infinite line charge density. It's a 2k lambda by r. Now let's find out the direction of electric field. Now for direction of electric field, please guide me. What should I do? Yes, this is plus lambda. So for this, direction of electric field will be in this direction, lambda 1. This is minus lambda. So for minus lambda, direction of electric field will be radially inwards. Yes, you are correct. It's an E lambda 2. As both vectors are having the same direction, both vectors are having the same direction, so they must be added. So this E net would be is equals to 2k lambda by r plus 2k lambda by r, and that would be a 4k lambda by r. If I write this, E net is equals to 4 into k is 1 upon 4 pi epsilon naught multiplied by lambda, and my r is r by 2, as it is the exactly midpoint. So this r, this would be 2. So 4 would be a gone, and the remaining term is 2 lambda divided by pi into epsilon naught into r. This is E net. What was your answer? Did you make the same thing? Did you? Great. Do it fast. The time is going. Next question. Look at this very carefully. What they have provided. What they have given is that the electric intensity outside, it is outside a charged sphere of radius r at a distance r, and as they mention outside, that means r is greater than r. So the situation would be look like this, that this would be the sphere, this is its radius r. You require an electric field at this location, this is r. Yes, you required an electric field at this location, and suppose they have provided a charge q and surface charge density is sigma, because all the options cover only the sigma. So what can I do? Let's say electric field at point P would be is equals to k multiplied by q divided by r square. But the problem is I am not having an q as an option, but I am having a sigma of it. So let's rearrange the things. I know that sigma is equals to q by a, so I can write as q is equals to sigma multiplied by, look at this, this is sphere, Don't make a mistake by pi r square. It's a sphere. Area of a sphere would be a 4 pi r square. So if I rearrange the things, E should be is equals to K, that is a 1 upon 4 pi epsilon naught, multiplied by Q, that is sigma multiplied by 4 pi r square, divided by square of the distance. This is small r square. So this 4 pi had been gone, and this is sigma multiplied by r square, divided by epsilon naught into r square. This is electric field. This is what we require. Are you sure? Are you sure? Yes, this would be the correct answer. Yes. Let's find the next question. What they have given is that three charges minus of q1 plus q2 and minus q3 are placed as shown in the figure. And what I need is I required only the x component of the force on charge minus q1 is proportional to that. I am interested in proportionality constant only, not on a perfect answer. Now let's look at the graph, or look at the diagram. What they have given, they have put up a minus q1 here, plus q2 here, and minus q3 here. Yes, this is the situation they have given. Now what they have been asked is they are interested in only the x component of force. They are interested in x component of force. So what could be the situation? What could be the situation? X component of force on which charge? Force on minus q1. Yes, minus q1. They are interested in the force on the minus q1. So let's begin. This is minus q1, this is plus q2, this is minus q1, this is plus q2. So what would be the situation? This is negative of charge, this is positive of charge. Yes, so if both are of opposite polarity, both are of opposite polarity, then it should be moving like this. Yes, it should be moving like this. Now this is minus of q1, this is minus of q3, both are of same polarity, both are of same polarity, so it should be moving like this. This is the force due to 2, and this is force due to minus of q3. So if I make a component of this, this is the f2 cos theta, and this is f2 sin theta. Are you done with this? Yes. Now we are interested in x component. This is x, this is y, so we need to just add these two forces. Now if I take a first force, it's in k, that is 1 upon 4 pi epsilon naught q1 into q2 divided by their distance, it's a b square, plus k multiplied by q1 into q3, this is q1 into q3 divided by their separation, it is an a square, but it is multiplied by sin theta. So if I find out the proportionality constant, if I take a proportionality constant, let's look that q1 can be a constant, q1 can be a constant, it is having by both a 1 upon 4 pi epsilon naught, that is what we call as in k, it would be a constant. So if I make a constant k and q1, it's a k into q1, so the remaining term would be q2 by b square plus q3 sin theta by a square. This is our answer. So are you done with this? How did you do this? Did you do the same? Are you sure? Great, great work. Let's look at the next question. Let's go through this. Next. Do it quickly. These are the very simple questions. Very simple questions. Let's look that what they have given is charge q2 of mass m revolves around a stationary, okay, it is at rest, in a circular orbit of radius r. The orbital periodic time of q2 would be, this is what they have asked. What could be done? A charge q1 is stationary, and here charge q2 is there, is moving around. So what are the forces? that is acting on this. A first force, a first force that is acting is electrostatic force, which is K Q1 Q2 divided by R square. Yes, and as it is moving in a circular orbit of radius r, that means it is a circular motion, and if it is a circular motion, centripetal force must be there. Now here I have to find out the orbital periodic time, so I can replace this with m omega square r. So here this centripetal force would be provided, centripetal force would be provided by the electrostatic force between these two charges. So I need to compare this to k q1 q2 by r square, that should be is equals to m into r into 4 pi square by t square. Now what you require? You require this t. Can you do this? Are you sure? Are you sure? Will you be able to solve this? Are you sure? Okay, then do it yourself. But I want to add up certain questions in the same question. So you need to first task is you need to solve this and find out the time, and also find out that what would be the correct option, as well as let me add something, that first find velocity of q2, second find frequency of q2, third find kinetic energy of system. So this is the add up of these questions. Yes, so you need to perform this three numericals, as well as you need to solve this and find out which would be the correct option. Are you sure? Done with this? Ready to move next question? Are you sure? Let's look. What is given? The given data is a charged particle is there, which is having a this much amount of mass, is held stationary in a space by placing it in a downward direction of electric field of this much, then the magnitude of the charges. First, look at this. They have said a charged particle. They did not say a positively charged particle or a negatively charged particle. So that decision must be taken by you guys, that which kind of charge it would be. First thing. Second, is held stationary. That means a net force on that charged particle must be a zero by placing it in a downward direction of electric field. So they are sure that electric field is in downward direction. If electric field is in downward direction, and if this charge needs to be, in an equilibrium, then consider that which are the forces could be acting. First force that must be acting is m into g, it's an mg. Now if I need to balance an mg with qe, then I must apply a qe here. But they have said it that electric field is in downward direction. But this could only be the option if charge is of negative polarity. Charge is negative. If charge is negative, things can be done. So let's say charge should be a negative. Now I need to balance this. But the forces mg is acting downward, and the another force is qe that is acting upward, and I said it has been stationary, that means these two forces must be equal. So I have equate this, mg is equals to qe. Now put up the value. Look at this. This is gram. Do not tempt it. Do not tempt by this. It is that needs to be converted. This needs to be converted into kg. Yes. And charge is given and electric field is given. You required to find out the charge of it. So will you be able to solve this? Yes, this is a simple numerical task that can be done, I'm sure for you. So let's do the next question. Now what is given? Very very easy question. Very easy question. This was asked in the JEE. This was asked in JEE. Again, mains, not in advance. But just look at this. What they have given is that 2 point charges are there. 2 point charges are there, and they are the plus 2 coulomb and plus 6 coulomb, and they repel each other. They repel each other with a force of 12 Newton. If a charge of minus 2 coulomb is given to each of these charges, the new force will be. So first what I need to do is I need to find out a new charge. A previous charge, it was the plus 2 coulomb. If I have been add up this minus 2, this would be a 0. To a great surprise, this is 0. And the next charge would be equals to plus 6 coulomb minus of 2 coulomb, it would be a plus 4 coulomb. So I know that force is directly proportional to the q1 into q2. Here it is q1 dash into q2 dash. As it is a 0, nothing matters. So new force would be a 0 coulomb, or 0 Newton, sorry, my mistake. A new force will be a 0 Newton. Are you sure with this? Are you? Will you be able to solve this kind of question? These are very basic questions, very very basics, but they have been asked in examinations. Yes, next. What they have given is, what they have given is, which of the following plots represents the variation of the electric field with distance from the center of a uniformly charged, look at this, non-conducting sphere of radius r. So before you go with this, you must know that what should be the electric field, or what are the relations of electric field for different locations for non-conducting sphere. So let's just revise this. Let's say this is charge q, this is radius r. Now if you remember this theories, we were interested in three sections. One, at location this, where r is greater than r. One on this location, where r is equals to r. And one on location of this, where r is less than r. So in first, this is first, this is second, this would be the third. So in this, E would be is equals to k q divided by r square. In second case, where r equals to r, E would be is equals to k q divided by r square. And in third case, where r is inside the sphere, or r is less than r, we must write that it is k q r divided by r cube. This is the relation. Now what you need to consider is, if you wish, you can go through a question one more time, which is essential. They want to plot an electric field versus distance, not a radius. First make these things clear in your mind. They require a graph for electric field and distance, not an electric field and radius. And you need to consider the distance from the center. Yes, so you will begin your journey, from the center, will moving towards the surface, and then moving out of the sphere. Are you sure? So when you are inside the sphere, sphere, so that E inside would be directly proportional to the r. Here it shows. And once you are moving out of the sphere, E outside, it is 1 by r square. Here it is shown. So this would be the correct graph. E is directly proportional to the r up to when? To you have not crossed your radius. And as you have crossed your radius, it is 1 by r square. So are you done with this? Are you sure? Are you done with this? Yes. Okay. So this question has been done. Now if I want to ask one more thing, then which of this graph, all things are same. If I replace non-conducting sphere by conducting sphere, if the questions has asked for the conducting sphere, which would be the correct answer? For the conducting sphere, inside electric field would be a 0, and so would be the first option would be the correct answer. It is a 1 by r square. It is a 1 by r square. But from where? So from radius r to distance r. So electric field will be available as you are moving away from the sphere, or you are moving just outside the sphere. Inside the sphere, electric field will be a 0 for conducting sphere, but for non-conducting you have already proved this. So are you done with this? Are you done with this? Are you sure? Let's move to the next question. What they have given. What they have given. What they have given is a cube has given. A cube has a point charge of minus magnitude minus of cube as all its vertices. Now you need to find out electric field at the center of the cube. What can be done? First, let's redraw the situation. Point charge of magnitude minus of q at all its vertices. Yes. So at all these places, yes, electric field at the center. This is the center. This is electric field at point P. Now you must know that. You must know that if I make a distance x, let's say this is the distance x, then this must be the distance x. This is the distance x, this is the distance x. So electric field due to all charges will be same in magnitude but opposite in direction. So E net would be equals to 0. This would be the correct answer. Yes. Did you assume it? Yes. Great work. So let's wind it up here. This is session 2 of the previous year asked questions. We are planning at least one more session, or it can reach to the two more sessions of this kind of, that means the only previous year asked questions will be discussed. But I request you to revise this unit completely, to revise this unit, then and then only this kind of session will be helpful to you if you have revised it. If you have not revised it, this is none of your use. So please revise this, because I want when we move to the next lecture, we must be pretty sure that I am confident enough with unit 2. I am confident unit with the 2, as as my unit number 1 is completely done by faculty as well as by student. I hope you understand this. So please practice it. This will be very helpful for us. So let's shut it down. Bye bye. Take care. Have a good day.